Chapter 6, Lesson 5, Subtracting Integers on a Number Line and with Counters. So when we subtract integers on a number line, it's different than addition. And the way you write it is instead of having two arrows, you only have one arrow. So if my question is positive 8 subtract negative 3, you mark 2 points on your number line. You mark positive 8 first, which would be here. And you would mark negative 3, which would be here. And the first integer becomes the end of the arrow. And the second integer becomes the start of your arrow. So therefore we're traveling from negative 3, which is the start of the arrow, to positive 8, which is the end of the arrow. And the direction of the arrow tells us whether it's positive or negative. So our arrow's traveling to the right, so we know that our answer has to be positive. And what it's positive by is the amount of numbers it travels. So if we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer would be positive 11. In our second example, we have negative 9 subtract positive 4. So same thing, mark our points. Negative 9 is here, positive 4 is here. Our first integer is the end of the arrow, and our second integer is the start of the arrow. So our arrow is traveling to the left, which means that it is negative. And how many spaces to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And our answer is negative 13. When subtracting numbers with counters, we have two examples here for you. So the first one is negative 7 subtract negative 3. They are modeled here with 7 blue counters representing negative 7, 3 blue counters representing negative 3. When you subtract with counters, you want to get rid of the right side or the bottom row, depending on how your integers are shown. And by doing that, you can cross out like colors with like colors. So blue with blue and red with red. In this case here, we have all blues. So we can subtract a blue with a blue, a blue with a blue, and a blue with a blue. And whatever is left in the top row or on the left side becomes your answer. So the answer for negative 7 subtract negative 3 would equal negative 4. In our second example, we have positive 8, which is shown with 8 red counters. Subtract negative 2, which is shown with 2 blue counters. And we want to get rid of our negative 2. But we have no blue counters here to cross them off with, like in this case here. So what I have to do is I have to add in a 0. So if I add a positive and a negative, I've added a positive 1 and a negative 1. So mathematically, I have added nothing. I've added 0 to this question. But now I have a blue to cross off with a blue. So I will add a second 0, positive and negative. And now I have 2 blues, 2 negatives to cross off with 2 negatives. Now that this side is empty, I count how many red counters are on this side, which is 10. And my answer is positive 10. Thank you. Our next two examples are negative 6 subtract positive 3. In this example, I have my blue counters, which represents negative 6 on the top or the left side. Subtract positive 3, 3 red counters. Remember, I have to get rid of these three red counters, but I cannot do it yet because I do not have any red counters on the top. So I have to add in 3 zeros. So I have 3 red counters available for me. Now by doing this, I can cross off a red with a red, red with a red, red with a red, and I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9 blues. Blues stands for negative, so my answer is -9. In my last example, I have +6 subtract +2. I have 6 red counters and 2 red counters. Because they are the same color, I do not have to add anything in. I can just cancel out 2 reds with 2 reds. I am left with 4 reds. Red is equal to positive, so my answer is +4. Thank you.